Hello students, today we will understand why the transformers produce a buzzing sound. You know, if you have ever been near a transformer, an electrical transformer, especially the supply transformer, you will see that you will hear some buzzing sound, right? And that buzzing sound has got a frequency which is twice of that of the supply frequency. Supply means the AC frequency which is supplied to it. Okay, now what really happens? Transformers, what are they? The transformers are you basically there are two coils. One is a primary coil, one is a secondary coil, like a spring, let's say. Yeah, a kind of there is a core of ferromagnetic material, and a wire is wound around it, and then we supply current, and this current flows through in the same fashion, right? If the current enters, and if for one coil, where you can see if it is anti-clockwise on one coil, then again on every coil that is facing towards you, it will be anti-clockwise, correct? Right? Then and nothing, there is nothing, no moving part in a transformer actually, at least as far as the design is concerned, right? But some motion is introduced because of its functioning. Okay, let's understand where does the motion come from. It's just current flowing through the primary, creating a varying magnetic field because of the current supplied is varying, or the voltage is being is varied, and because of that fluctuation, the flux of the magnetic field linked to the secondary also fluctuates, right? And because of that, there is an induced EMF in the secondary. That's all. But then, where does the motion come from? Well, how does the electrical power supply create mechanical power in the transformer, which is actually not a desired effect, but that comes at a as a kind of a byproduct of the entire mechanism. Let's understand. So if it's a coil, let's suppose take a primary only. There are three types of inductions happening, right? In a transformer, the primary coil goes through self as well as mutual with the secondary, right? So self and mutual are both there. Just consider any one of them. The current is being supplied. Okay, the moment when the current is starts to flow in this primary or secondary, whatever it is, so you will see either it will be not anti-clockwise or clockwise. If it is anti-clockwise or clockwise, whatever it is on one coil, then every coil which is facing towards you, you will have the same rotation of current. So far clear? Now let's just imagine that I have like this, like two coils. Let's just take two coils, adjacent coils, right? One is north, this one is also north. You see both of them are giving you a sense of rotation, that is anti-clockwise. So north pole on this, north pole on this. So basically this is how they're stacked on each other, right? One after the other, correct? Very closely packed. Yes. So think about it. Now let's just look at the back side of this one. If it is north facing towards you, what kind of rotation is it going to create on the other side? Automatically it will be south, right? So if it's north pole facing towards you, the opposite side will have south pole. Now the other one, which is just behind this one, also has a north. Now the south of this is facing the north of the other. Now south and north, what will they do? They will definitely attract each other, and that attraction will exist as long as there is a current flowing through that coil. Yes, the moment when the current becomes zero, what happens? No repulsion happens. Done. Nothing. No force. No force. No force. That's it. Correct. So if I bring you the coil again, so once there is a current, the coil is compressed because each loop is attracting the nearby loop, because always opposite poles are facing, right? Now it is, when the current is zero, it simply comes back to its natural length. Note, there will be no repulsion. Why? Because no matter in which way the current goes, right, it will always be opposite poles and they will always attract. Simple. So that in an AC, if you can see, the electrical power supply in the red curve here varies like this. Okay, it starts from 0, goes to the maximum, goes back to 0, goes to the minimum, comes back to 0. So in one complete, because at this particular point it will be another cycle. So in every cycle for the electrical power supply, there is 0 how many times? Once, and first, second time 0. When it becomes third time 0, it will be part of the next cycle. Clear? So for electrical AC being supplied to the transformer's primary, current becomes zero twice. So twice it will be relaxed. So here it was here no force when the current is zero, becomes maximum whenever the current reaches maximum, whether negative or positive, then becomes zero again. So for one cycle of AC, there are two cycles for the mechanical vibration. So in India, we usually have 50 hertz AC supply, right? So the transformer frequency will be twice of that, which is 100 hertz, almost near that. There are other factors also. We're not going to go deeper into it. But in US, it's 60 hertz. That's the standard frequency of the AC. So the transformer buzzing will have a frequency around 120 hertz. Okay, so now I think you've understood this. See you in the next one. Bye bye.